But, so
Without me, yeah.
today I want to talk to you about
make a lot of
HP Flex Campus Mobility. And how many people have heard of the Flex network architecture? I'm sure you've been involved with that. But we built this architecture around networking. So it integrates Flex Fabric, which is the data center, Flex Campus, which integrates wired and wireless together, Flex Management, and then Flex Branch, which, out at the branch office, which brings everything together, wireless routing, services, and everything else. So one of the things I live by is wireless is an art, not a science, right? How many calls do you get in a day, and you guys work in high tech? Will wireless do this, X, Y, Z, right? And they want a solid answer. Will it support, 100 clients? Well, that depends, So it's more of a art than a science, and giving straight answers. So that's why I always like to do that. So what I want to chat about today is just a HP and mobility overview. We've just released a 466-R outdoor access point. So it's basically, if you look at the 466, we put this in a enclosure and made it for outdoor usage. It has a heater in it, everything else, but it's based on the 466 product. So it has all the features, functionalities, except that now you can put it outdoor without having a separate NEMA enclosure or building something around that. Next, I'll talk about the MSM466-R mobility access controller. And HP had a hole in their armor. So we had the MSM710, which supported up to 10 APs. Then you got into the 760, 765, which was 200 APs. And we had this huge gap in between there, anything above 10, below 200. So the MSM720 kind of fills that gap because it'll support up to 40 access points. So it kind of fills that gap in between. And then we'll take a look at the new 5.7 software interface on the MSM controller, because there's been some workflow automation stuff put in there, because most people, or a lot of environments that are large enterprise, just want to set up a guest access, they want to set up an employee, and be on their way and start deploying APs. So we've created workflows inside the MSM product and some other enhancements. So we'll actually do a demo on that, which I'm running on a VM image on my laptop. And then go questions and answers. But I want to keep this interactive, so if you have any questions, if I'm going down the wrong path, you guys want to talk about something else, let me know. This is your time, and I really don't want to waste it, so, okay? So, here's the Flex network architecture. It's built up of the Flex Fabric, which is a data center, Flex Campus, which we're going to talk about today, which is really the integration of secured wired and wireless. Flex Branch converges the network functionality for security at the branch office, routing out to the branch, enhanced services such as if you're running link, survivability, all that fun stuff in the branch office. It's all managed through the Flex Management architecture, which is based upon IMC, the single pane of glass that you might have heard in the industry. So the idea behind the Flex Network architecture was to keep it open. And what we mean by open is we want to use open protocols and standards-based standards-based protocols, standards implementation of those protocols across boundaries. So that allows us to integrate with any other manufacturer as long as we're implementing standards-based protocols and standards-based implementation of those protocols. Keep it scalable. So in the enterprise environments, they're always changing, moving. People are getting acquisitions, so we want to keep the network scalable, keep it secure. So everything from running NAC to using IPS for intrusion prevention type stuff. Keep it agile so we can move, change, make changes as we go, and have a consistent experience from a customer's endpoint, right? So if you come into this facility, sorry about the wireless connection issues, but theoretically you should have the same consistent experience whether I plug into a network or I come in through the wired network, right? So we want to keep everything consistent. All right. Next, I want to talk about site surveys. I've always got to talk about this. Every time I go out and present, I talk about site surveys. Every time I've ever been brought in to where a wireless implementation has failed is because somebody hasn't done a site survey or redone a site survey. And what we're seeing a lot in trending out at the larger companies are they're swapping out their 802.11 AG access points for what today? 802.11n. Now what they haven't done is another site survey, right? So all of a sudden, where they had coverage, they don't have coverage anymore. Or where they didn't have coverage outside the building, now they have coverage because of the reflectivity, other things in wireless. And that's why I always call it an art, not a science. So we always want to go back and redo a site survey. And it doesn't matter whether it's HP and Aerohive or whoever you're going to see, we got to do a site survey. So there's 3 types of site surveys that really need to be done. First of all, you want to do a predictive site survey. So you want to use a tool such as AirMagnet, Ekahau, our RF planning tool, to actually sit down at a desk, bring your maps of the facilities into your predictive tool, scale them out, and then do a simulation to say, hey, before I go out and actually walk the site, where should my access points be? What is my expected coverage areas and all of that? It's an invaluable tool to have. And like I say, HP uses HPRF Planner. Ekahau has a tool, AirMagnet has a tool. I don't care what you use for that, but just please do a predictive site survey initially. So it brings all your maps together and gives you a good idea of where APs are going to place. Next is a passive site survey. So what the passive site survey says is, okay, now I've done my predictive, now I'm going to take my tool and walk the environment. So I'm going to walk around and see what's out there for RF. Look for interference, look for obstacles, look for things like that. So it gives you a solid base for your environment. And then the last part is the active site survey, where you want to go out and take a look at the environment and put a client in so you get a true reading of what the endpoint's going to look like. And when I'm talking about active site survey, so if I have a warehouse floor and I'm running barcode tools or handhelds or whatever, do I do a site survey with a laptop with a full powered card? No, you want to go out there and do it with a device that you're going to be utilizing for that area. But with those 3 together, you're going to be moving forward and have a successful implementation. Yes?
So I don't mean to be rude, but everyone in the room here, this is the stuff that we teach. And so we're really interested beyond how to do a site survey and stuff.
Okay.
Stuff, we're probably good.
Yeah, most of it is what we do every day.
Okay.
So,
perfect.
I mean, the basis of wireless, I think we're good with.
Okay, I just like bringing it up.
Sure.
It needs to be brought up. Okay, so a trend in the industry, and I'm sure you guys are beating this one up, is to bring your own device. We all understand the bring your own device, the importance of it. All the enterprises are embracing the premise of bring your own device in. And when we walk into a room like this, everybody knows, so I see phones out on the desk, laptops, I'm sure there's tablets and bags and stuff that are connecting to the network. But enterprises are embracing this, everybody's embracing it, but it's a huge problem in the industry. Now in these access points, getting back to site survey, we took these site surveys. I put these with an estimated amount of clients coming to this access point, right? And the coverage area and the amount of clients performance. Now when I come in, and where I used to have 1 device, I got 3. So we have to take that in consideration, and I'm bringing this in because of our new access points that will help solve that problem. All right, I'll skip over these then. One thing I do want to talk about is the architecture of the MSM product set. So in the controller environment, we have our MSM products, and I don't care whether it's the 720, 760, 765, we'll get into each of those. But we have 2 types of architectures that we can run. First one is we call it distributed or local switching. So we basically put the control traffic back to the controller, drop the data traffic on the line. The second one is the tunneled back. Most people have this nowadays, but you really need both of them because you want to separate off your bring your own devices, your enterprise environments, but you also want to, in wireless environments, we have PCI compliance, right? Anybody in retail, HIPAA requirements, Sarbanes-Oxley. So we have to have ways of being able to audit that. So that's the key importance of being able to also be able to tunnel back to the controller so you can maintain those databases and get that required reporting that you need to maintain those certifications. Okay. So HP technology, what we've done is HP's built a 3x3x3 MIMO. So 3x3, 3 transmit, 3 receives, and 3 streams. So out of our APs, we have 2 versions of the APs. We have the 430 and the 460 series. But we get 50 times higher performance, and then about 1.5 times more users. So in a typical environment where we used to be able to do high HD streaming on a 3x3 with two spatial streams, we get about 10 users with a high definition stream, 1080p. Today with the 3-stream, we can jack it up to about 15 users on a 3-stream radio. Part of the thing with HP is getting that, I talked about it, getting that ubiquitous experience, right? Whether I'm wired or wireless. And part of that is through management, right? Identifying what the endpoint is, being able to get all your wireless statistics, being able to manage it, you know, from day-to-day backup to configuring users to Active Directory and stuff. So with our PCM Plus, our Identity Manager and Mobility Manager, it's all a single package, but it's modularized. You can manage it, have one unified network, and get that experience whether you're wired or wireless.
Go back a slide. Oh, a couple, I guess. So, is the MSM, or do the switches have microcontrollers in them as well, or does it all go right back to the MSM? Because when we were here last time, there was something about a split hybrid model where the AP will keep going if the MSM goes away.
Yes, out in the AP. So so you can set up a high availability. So if you drop the controller, you'll still your data traffic will be dropped on the wire. So that's what I call local switching.
Okay.
So it's defaulted that way. So when you plug your AP in, your data traffic dumps on the wire. Just so from your AP to the client, it's encrypted, and then we dump it on the wire, and then let your policy, the rest of your networking policy, take care of it.
So without the MSM, it continues to do so?
It'll continue to run,
How
yes.
does it authenticate if a new user wants to authenticate?
You won't
with your apps?
authenticate.
Okay.
You won't authenticate.
So in survivable mode, it's just active users. It's not serving new users.
Exactly.
Okay.
But typically today you'd go, we'll talk a little bit about it, teaming.
Sure.
So if you set them up in a teaming environment, which is an N+1 environment, you'll have it scaled up enough to where the controller isn't a single point of failure anymore. So HP networking mobility, here's what we're all about. Single pane of glass management, right? So whether you're doing integration to Active Directory, whether you're checking on performance of the wireless network or whatever, we have a single pane of glass that you can look at and get to all that information. We have wire-like performance with the MSM466 products and the 460 products, because we're running 450 megabits per second out to the client. And one of the cool things is with the MSM466 and just the MSM466, we can run both radios in 5 gigahertz mode. And with the advent of 802.11n, the new paradigm shift is to 5 gig anyhow, because that's where most of your channels are at. But we can take an AP now, and I can have a 900 megabit cell, which is pretty slick. And it only works on the 466, not the 460, because of the inherent, we use inherent radios, antennas in the 460, which is not enough separation. You know, and there'd be a lot of interference. So that's why we only allow the dual operation with the 466 products, because we can separate the antennas out. All right, next is unified access control, consistent wired and wireless, intrusion prevention. We have a product called the RF Manager, which is a layover product. It can use our access point, but what it does is it does intrusion prevention on the wired and wireless network. So when you have to maintain like PCI compliance, you have to get those reports, Sorbet-Knoxley reports, HIMSS reports, things like that, we can pull it out of that RF Manager product. And it works in conjunction with the MSM product. And enough of
How
the
do you guys do
TCO.
like licensing? You know, if you want to add like IDS, IPS, are you doing like feature licensing in the controller?
The IDS, IPS would be a separate box, and then you licensing against that server.
Okay.
And then I'll talk about licensing on the MSM controller itself. You just buy it in blocks of 10.
Okay.
So, any questions? Okay. Now I'll get into the product sets. So the new access points are the 430, 460, and 466. The 430 is a two spatial stream version of the 460 and 466. Each of them are 3x3 MIMO. Each support PoE power only. You don't require PoE plus to run them in 3x3x3. So that's an advantage in the environment. The 430 and the 430 and the 460 look exactly the same, and their antennas are integrated internally. And they're a 4x7, and I'll get into specifically what the antennas. They're PIFA antennas, quarter wavelength type thing, and we'll get into that. They're RF optimized features, so we support MCS rates 0 to 23 because of the third spatial stream. Standards-based beamforming, so this is chip-based beamforming. It's explicit. It can be compressed or non-compressed, and I'm going to talk about that feature in more in depth and what it is and why it's important. We also do something called band steering, which allows us to divert 2.4 5 gig capable radios to the 5 gig side versus 2.4. And then concurrent radio operation in the 5 gigahertz band, we discussed that a little bit, only on the 466 products, not on the 460. Because anything with the internal antennas, we can't get enough separation without providing interference.
I want to clarify, you said these are the new APs?
Well, they've not
They're your newest?
newest APs.
Okay, I just
yes.
wanted to make sure I didn't miss, that there was a different one out there.
There's a different one.
These are
The outdoor version.
These are like April last year, right?
April, May of last year, and then we just released the 466-R, which is the outdoor version of all this.
Okay,
Okay?
thank you. I appreciate
No
it.
problem. We provide PoE. Like I said, we only need PoE. We don't require PoE plus. We support 200 milliwatts EIRP output power, so it's maxed out right across the frequency. We can run it in an AP meshed or monitor packet capture modes, operating temperature, and they're plenum rated, so you can stick them up in the overhead. So some of the RF optimizations are band steering, automatically redirects 5 gigahertz capable clients over to the 5 gigahertz side. Concurrent operation in the 5 gig band, 466, 466R. Benefits are improved noise immunity, fewer sources of interference, increased channel availability, and higher utilization of the 40 megahertz channel. Because really to realize the speeds and feeds of 802.11n, you have to run into 5 gigahertz and run 40 megahertz channels. Right, use short guard interval, all the other enhancements of .11n, and then standards-based beamforming. And these are features that I'm going to chat about right now. Yes.
Oh, if you're going to get to beamforming later in a deeper dive, I'll wait.
I'm going to get into it in a deeper dive. What it is, why it's important. So we have a number of external antennas. On the 466, there is no antennas inside the 466. So just so whoever, repeat that one more time. Inside the 466 products, or any of the 466, there are no internal antennas. I've had people buy these before and wonder why they're only getting a cell about this big. So there's no internal antennas.
It's called leaky antenna technology.
Exactly. They got a little piece of wire about yay big. So, but we offer a range of deployment antennas. We have indoor antennas. We have 2 indoor antennas for 3 and 4 dBi. They're all both omnidirectionals, and then we have 2 outdoor antennas for a narrow beam sector and a directional. And these are going to be important when I talk about the 466 outdoor environments. Different mounting environments. You can adapter plate, wall mount, ceiling mount, T-bar mount, however you want to mount these APs. And they use the same ones because if you look at the footprint of the 460, 430, 466, they all have the same footprint. Parts are interchangeable except for the internals. We're good. So here's the specifications on that. I'll give you guys these this presentation, but we get into what the flash, DRAM, everybody's always interested in it. But these are the type of antenna that we utilize internally in the 430 and the 466 is a PIFA style antenna. That's actually physically in the product.
Can you explain that?
This stands for the planar inverted F antenna. It's a small ground plane antenna, quarter wavelength, and has short pins.
Mm-hmm.
That's the type of stuff that we geek out over. Antenna design.
Nerds.
Exactly.
Nerd.
But as you can see, that 430 and the 460 have the antennas internally. The 460 and the 466 do not. The 466 has reverse polarity SMA connectors. That was FCC and above said everybody has to have a unique connector. And then the outdoor antenna has a N-style connector. Because if you go outdoors to most of the outdoor RF guys and look on their websites, everything outdoor from lightning arresters to cables to everything else is end style connectors. Temperature ratings, enough of that said. One thing I do want to point out is we do have gigabit interfaces on all the products you have to have for 8.11n, and encryption is actually done in hardware in the product.
Any plans to do multiple gig ports and do LACP or failover or anything like that?
It might be a roadmap item, and I cannot comment on roadmap items right now. Yes?
Does the 466R have some kind of heater or something? I'm just noticing that when you put it below -20, it requires AT. What's the...
Yes, it does. And once we get to the 466, I'll talk about that. But yeah, so there's actually a heater in there that if you want, it's like environments where I live in Green Bay, Minnesota, when it gets very, very cold, it'll kick in. It's just a short heater in there that'll kick in, but it does require AT power to kick in that heater. But if you're in a warm environment, such as Florida, and you don't get that warm, you can run it off of standard AF power. Okay? So we need that extra wattage to kick on the heater to keep it warm. Here's a frequency band that we operate in. So we use standard channels 1 through 11 and the 2.4. We support 36 through 48. The one I want to point out is the 5.5 to 5.7. We exclude the 120, 124, 128, and 132. And then we support 149 through 165. You guys geek out about this stuff? Here's a functional block diagram of the MSM430 and 466. So standard, we have flash, we have RJ45 into it, 120 mega DRAM, we have our GigaPHYs, power system, AF/AT classification, dual core processor, our Atheros radios. We use the AR9390, they're 3x3 MIMO radios, and then we connections to the antennas.
So
I do have one quick question about the dual core processor. Did they say something last year about it's only using one of those cores right now, or is it now using both cores?
It's using one core now, and the other will be used when we implement the IPS IDS stuff
yeah.
concurrent with the
Okay.
yeah.
Just wanted to make sure.
Yep.
So IDS and IPS is coming.
No.
The other stuff.
But it'll be implemented. Yes. Okay. So features. Band steering. Okay. Band steering is designed to help. You got a question?
Oh, I was just going to ask, when you enable the second processor, is it going to require more power at all?
No.
Okay. Go ahead.
As far as I know today, no. But just in case, our classifier is AF/AT.
Okay.
We do have an AF/AT classifier, just in case something does have to happen that you have to jack up the power. Okay, features, band steering. Band steering's helped to solve dense client issues, right? Typically, when you come into an environment, what's the first radio that everything looks for connectivity on? 2.4 gig, automatic, boom. Throws it out there, says, hey, do we have that? In an 802.11n environment, are you going to realize any performance out of your mobile devices, laptops in the 2.4 gig range? Typically not. So when we set up environments at 2.4, we keep as the garbage band, I call it, because that's where we want all our .11g and B devices to connect to. And if you have .11n, you should be out there using the 5 gigahertz band, 40 megahertz channel, short guard interval, MAC enhancements, the whole bit, being ready to go at 450 megabits per second. So with band steering enabled, what happens is a wireless client who's AN capable in the 5 gigahertz band will try to go to the 2.4, but what we'll do is we'll ignore it. We'll say, hey, for 200 milliseconds, we'll ignore it for the association request, and once we don't get back, the 5 gigahertz will accept you and then put you on a 5 gigahertz band. So that's basically band steering in a nutshell. Just, you know, cleaning up them and directing your 5 gigahertz capable clients to the best performance possible. Here's an example of band steering. The device looks for the best signal. The device finds it's 5 gigahertz capable, and it will connect over to APB on the 5 gigahertz side. It's as simple as in the management thing for the wireless LAN for the SSID. check a box and say turn on band steering.
Are those probe response values adjustable? Like the 200 millisecond?
That's non-adjustable. This is
Does it-
done in,
Okay.
yeah, because the only way you can, like I say, here's how you would turn on band steering. There's no adjustability in there, yes.
Is that done like with any smarts in the background so it doesn't delay like voice calls, or is it applied to different voice Q or QoS queues, or is it just applied to everything?
Applies to
Per
everything,
W.
per SSID.
So if you have increasingly as wireless administrators, we can't separate clients based on the applications they use. They're becoming more and more integrated, where it's doing data, voice, video, potentially all in one
Understand.
device. And so, SSID separation is great. A couple of years ago, I think we're getting to the point where, everything's going to be merged onto one SSID, and we can't separate policy like that. So I would say, as feedback, I would love to see some adjustment in the band steering so that we don't negatively impact voice applications or
So let me
clients
ask
that
a
have
question,
voice.
being the ignorant non-wireless guy in the room. So the band steering is going to occur when the client initially associates to the AP, right?
And roam.
And
So it's when you're roaming that you're concerned about it.
yes, because that 200 millisecond delay is essentially, it might, if there's only one AP that it's trying to go to, it either has to scan more channels to find the 5 gigahertz one, so that's time for the client to scan through all the channels to find the 5 gigahertz radio, or, if there's only one AP in the area, then there's a 200 millisecond delay, and that can, impact.
Right, I didn't understand the roaming aspect of it, because I figured if the band steering happened when the machine booted up and joined the SSID, then it wouldn't matter for whether or not you were classifying which way or the other, because they're all going to be on A anyway.
Yeah,
I
it's
didn't.
primarily a roaming
Okay, the roaming
consideration,
thing.
yeah.
Thank you.
Especially when you're on an active call. If you're not on an active call, who cares, right?
No, we don't care if those drop, really.
Yeah, but I think in some vendor documentation, they state not to enable band steering when you do voice.
For that reason?
For reasons of that nature.
Yeah, and I think some of the other, vendor documentation also states that they do it on a per queue basis. So if we see that there's been active traffic in the voice queue in the last 100 milliseconds or second, or I think it's configurable even, that they won't do band steering for that client and things like that. So, it's just those rigid policy enforcements where you're relying on the SSID and only that type of client and the application of that SSID. That was great when we had dedicated handsets for phones and things like that, but anymore, one device is doing everything. They're smart mobile devices. I can do voice, data, video on one device. And we'd just like to see more improvement from vendors on understanding that fact, and that we can't,
But on that device, you don't care about band steering.
If
Right.
he's-
Yeah, 'cause it's only got-
Unless you have a built-in 5 gigahertz radio.
Yeah, and there's some that are out there already with 5 gigahertz radios, and I think it's going to become more prevalent over time.
All right.
But also, I think it's real important because, all the other vendors we talked to talked about band steering. But I think everybody has their secret sauce. And being an engineer on the floor, when you're troubleshooting something, it's really important to understand exactly what that vendor's secret sauce is. So it's easier to interpret an issue if it truly is an issue. I don't necessarily believe that band steering is for everyone. I think it might fit a special need, or maybe you have a high congregation of clients and you're trying to manage them back.
And that's, and to your point, that's typically where we recommend using band steering. In an environment, a coliseum, a school auditorium or something, where you have a high concentration of clients and everybody's coming in with their devices. So if you're 5 gigahertz capable on the laptop, connect to the 5 gig, 2.4 on the phone, connect on the phone. In a normal environment, if you have a device that's 5 gigahertz capable in an enterprise environment, they're going to lock it down and say use a 5 gigahertz radio, or put a VSC or SSID just on the 5 gigahertz, attach that to the 5 gigahertz radio and have the best performance.
And then
Yeah.
just one more thing to comment on is that I think in the next 2-3 years, as more and more devices are going to be 5 gigahertz capable, we're going to be 5 gigahertz heavy, right? We're going to go right now. I think it's a nice mix, maybe perhaps, but as more and more devices become 5 gigahertz enabled, we're going to be top heavy on the 5 gigahertz side, which maybe not necessarily a bad thing, right? More spectrum, cleaner environment, but I just think we're going to start to see a boatload going to the other side.
Much
And what's nice about HP then, if you implemented these 466 products, if you have them in the overhead, then you can turn on the second radio to 5 gigahertz, which takes care of that issue and gets you quite a few years ahead.
Right.
So we're already pre-planning for it. You have your 2.4 once advent of 5 gig is here for everybody. Shut down your 2.4 and bring it up to the 5 gig on both radios. You got 900 megabits now in your cell. You're good to go.
And that's what I was going to say too, is that you can, with this AP, what I like about it is you do have the option of software defined radio, or you can put both of them on 5 gigahertz, and I think that's something that's rare. And I personally, from an enterprise admin, I like that because the dual radio APs that have 2, 4, and 5 radios in them, I mean, lots of times I want more 5 radios than I want 2, 4 because I don't want my 2, 4 radios as close together as I would put for high density areas, right? So I like being able to define the frequency band operation.
Now, specific with that, you mentioned 900. There's 3 radios in there. How you
Well,
get-
we had 3 streams. So
Okay,
each
okay,
radio
gotcha.
do 450 megabits, and you combine them together, you'll get the 900. One of the cool things too is 5 gigahertz doesn't traverse as far as 2.4, right? We all know that. You get a little bit longer stretch. So you can mix and match the 430s, and the 430, 460, 466. Have the 466 because, and then for your 2.4 stuff, maybe throw up a 430 where you don't need the best performance in the world, because if it's doing already 300 megabits per second and you got 54 devices out there, it's going to be backwards compatible anyhow for a few years. Pull it out or just turn it over at the point in time to a total 5 gig radio when you're ready to go. So you can kind of mix, match, and balance. Yes?
I'd like to get your take on one thing that we've heard from other vendors is that they're almost advising customers to run 11N with 20 megahertz channels so you get the frequency reuse even in 5 gigahertz rather than the top heavy data rate because a lot of mobile devices can't take advantage of that multiple spatial stream
Wouldn't
or
it be
double wide
dependent
channel
on-
anyways. So
Isn't it dependent on your AP density, whether you'd want to do it or not? In
yeah,
other
I think
words,
so.
if
That's
you-
why I'm asking his opinion on what your take is on 20 versus 40 megahertz channels and when you would use either or.
Well, high density areas, you'd want to use 20 megahertz channels. Depending on the application, if I'm streaming a lot of high definition video around my environment, I'm going to want to use the 40 megahertz channels. So it's not just based upon the RF environment, it's also based on what performance you need out of your applications. So you really have to look at your environment once you get your site survey done and decide, what is it, 20 some channels might be enough where you're not going to get non-overlapping channels for what you need in your environment. So it's really based on the site survey and based on the applications and the endpoints that you're going to be utilizing in that area. Like I say, it's an art, not a science. It's just really back to that. All right. So beamforming. Somebody asked a question about beamforming. Is that Andrew or you on the beamforming? Somebody asked a question on beamforming.
Oh yeah, I was going to.
Yeah. So transmit beamforming. We do our beamforming in a chipset, standard 11N beamforming. We support compressed and uncompressed, and we support the different techniques to optimize the signal strength at the station. So non-compressed beamforming, the client station calculates and sends a steering matrix to the AP, and compressed beamforming is which a client station sends a compressed steering matrix to the AP, a little more performance. And here's some notes that you have to realize. Is radio calibration is not required to use either of these 2 methods. It's only supported in the 430 and 466 APs. Not available in monitor or sensor mode, so it has to be in an AP mode. Support for only 2 spatial streams. And I'm going to get into exactly why you lose a stream when you go into beamforming. Because there has to be communication going on between the client and the AP, right, to redirect that signal. So you actually lose a stream in beamforming when you implement it. But it still might give you better performance based on the environment that you're in. So beamforming only works with wireless clients that are configured to support it. Most of the Ethos chipsets support it today on like the HP Elite notebooks models, 60, yada, yada, yada. But it's really a client AP interaction, right? So if a client doesn't support beamforming, it does us no good. It's a communication between the AP and the client to get the best performance out of the RF signal. So here's what beamforming is. Without beamforming, we can see the AP sends out the signal, everything's in phase. There's just 3 streams that go out. Based on multipathing and degradation of the signal or whatever, they can be, the signal will degrade, or you can get an out of phase signal, and 2 signals will cancel each other, which gives you then a single phase, and that's all you get at the end device. Now, if beamforming turns on, I can turn on when I turn on beamforming, now I can monitor what I'm getting and say, hey, I'm not going to receive these out of phase anymore, and then I can enhance my signal at the client. So you see why you have to lose a stream on beamforming? So beamforming with a 3-stream radio is very practical. Beamforming with a 2-stream radio becomes impractical because you lose a stream. That's one of HP's advantages. We can also work in a meshed environment. We talked about this. So 2 types of mesh. We have the local mesh wired node and we have the local mesh node. Local mesh wired node is the way you get the wireless information back onto your environment, Tom, and get it pumping through where you need it at. Yes?
We had a question from Twitter about your mesh, and they're wondering, The Socialist wants to know if you recommend IRF or Trill for multipath clustered mesh networks at this point.
We don't support
Either.
IRF or Trill and meshed wireless networks.
Okay.
Because IRF is really, back to Tom's environment, it's a virtualization of switches, bringing the 2 switches together.
No wireless mesh, it's an ATM switch in the sky.
Wireless mesh is just wireless meshing. It's APs talking to APs.
Right.
All right, so the 2 things we have to know is a wired node. That's how you get the RF back onto the wire, where everything is at, your servers and all your great information is at. And the local mesh nodes are your access points that connect in through the wire to wireless to wireless to wireless. Okay? There's 2 types. You have the, we call it the master, only accepts connections from the alternate master or slave nodes. So those are the guys that are out in the environment. A slave is typically your standalone AP that talks up, and an alternate master is if you lose your master node for communications and routing up, an alternate will take over. Pretty straightforward stuff, standard routing stuff. We support this in a controlled or autonomous mode. So you can take our 466s out there and place them out there in an autonomous mode. That means you have to touch every AP, to get it working. Or you can go to a controlled mode, and we support 3 different types of mesh. You support the repeated mesh, the point-to-point, and the point-to-multipoint mesh.
Do you guys have a recommendation on number of hops, of wireless hops that you do in your mesh?
Yes. And we have a deployment guide for that runs you through applications, bandwidth requirements, and I can, once we're done here, I can point you to that deployment guide. This is a large outdoor mesh configuration. Based on how much bandwidth this client can deal with way out here. So, we have a lot of vendors out there that say, hey, we can do 16 wide, 70 deep, 100 wide, 500 deep. Is that practical in a meshed environment, meshed wireless environment? So between this link and this link to here, I get what? Now I add these links in here, what happens to my bandwidth? I keep losing bandwidth as I go out, right? So that's what you have to be careful about with meshed environments on implementing them, is what your applications are and what performance you need out at the far edges of your mesh. So I think we can do 8 by 8 mesh or 8 by 16 mesh now, but do you recommend that? Maybe if you need 500K out here or 1 meg out here, it might be appropriate. But it's all based upon the performance that you need for your clients on the outside of the mesh. Even in a repeated environment, typically a repeated environment is going to be facility, your repeater, and another facility out here, right? For connection. You also have to be careful with that when you're doing backhauls, what you require for performance, including latency, not just bandwidth, including the latency to get out there. Okay? So those are considerations you always have to take in concern when you're setting these up. Okay. Any questions on those features?
So I guess you're just using dual radio APs there.
Excuse me?
You're just using dual radio.
Dual radio APs, yes.
One for 2.4, 1 for 5.
No. And we can also support, like in a meshed environment, where we'll use one radio for the link, the other radios to support the clients. Or on a repeated mesh, as we saw earlier, you can use one, radio to radio, and get better performance out of that. Because these will operate in both, 5 gigahertz.
So you could have 2 5 gigahertz radios running on one AP?
Yes, we can. On the 466 only. And that would be this one and the outdoor version of it. Okay. Any questions on those great features? All right. I'm going to go 15 more minutes, talk about the 466R, and then we'll take a quick break if you want one, get water, whatever. Okay, so the 466R. Here's what the 466R looks like. We have end connectors instead of reverse polarity TNC, outdoor environments, and we don't sell the cable in between, and all the light. We sell a lightning arrestor, but not a lot of the cables and connectors and different things that you may need. So we go with the standard end connection, which is a typical outdoor connection. All the sealant, everything's made. It's a great connection for outdoor environments. The 466R, this is a front. We have 3 end connections on it and 3 on the back. You have your RJ45 connection, and your lights. It can be either mounted on a pole. You can wall mount it. It has different mounting options. It is IP67 and NEMA 4X rated for water, salt, and fog damage. It's waterproof. The Ethernet PoE connector kit is waterproof. It has a reset the factory button that can be enabled or disabled. LEDs for health. Operating range from 40 degrees Celsius to 55 degrees Celsius, minus 40 degrees to 55. We have an embedded heater, and this was to a question over here, was about the operating with the PoE plus. So in environments, harsh environments that are cold, Alaska, Wisconsin, Minnesota, Michigan, those types of environments, then you need PoE plus AT power to actually turn that heater on.
So
Yes.
if you start selling into environments like Arizona and places like that, are you going to consider putting an air conditioner in?
Probably not. The cooling coils are hard to get on the back. And then the 55 degrees Celsius is a very high
Probably
range.
hotter than anything.
Yes. Okay. So this is a industry offer, a near gigabit wireless LAN client access in an indoor in an outdoor factor. It supports 3 spatial streams, 450 megabits per radio with AF PoE, so standard PoE. Concurrent operation in 5 gigahertz band. Like I say, it's a 466. Even though it has a -R, I can still run both radios in the 5 gigahertz band concurrently. Supports advanced and future wireless applications for high demanding throughput. Flexible antenna options. Like I say, you have the choice of omnidirectional, sector, directional antennas. It's IP67 and NEMA 4X rated. And that'll be for fog, salt. May see them in the ocean environments for salt. And standards-based technology protects your customer investment. And another way where you can implement these or deploy them is in a typical mesh today. You'll backhaul with 5 gigahertz and 2.4 for the clients, right? You see this in high schools, colleges, a lot of things like that. With the 5 gigahertz on both radios capabilities, now you can run the 2.4, support your clients and everything. Once, as the advent of 5 gig comes out on the laptops and on your phones and stuff, you can shut that radio down, turn it up on 5 gigs, and be ready to go.
Just a thing about that previous one, the near gigabit Ethernet WLAN client access. I mean, technically, if you think about how even running 3 streams on the AP, you can't get near gigabit speeds with 2.4 gigahertz. You'd have to run them both with 5 gigahertz radios, and you get interference. I mean, it's a bit of a stretch.
It depends how you look at it. Wireless is a shared medium, right? Now, if I have 10 megabits of shared medium to give, let's talk about the old hubs, right? Well, that's why we went to switches, and so we have dedicated to you. So this is shared medium. And theoretically, in this area, I can have, everything's perfect. I can have a cell that'll support 900 megabits of data. We've designed the 466 and 466R to allow you to have enough antenna separation so you're not going to get the interference with each other, on the radios internally. So you have enough capability.
This one, which can do the dual 5 gigahertz radio, right?
Yeah, it's the same as this, except instead of having 6 connectors on one side, you've got them on both sides. So
Okay.
this is the exact same as this, except for the new enclosure around it. The radio, everything is inside, is exactly the same as that product there.
Right. Even with either one of these, in order to get the separation from the antennas, you're basically doing directly from the antennas, pointing them in different directions. I mean, the client is not going to get anywhere near gigabit speeds. You might be able to be saying, yeah, we've got two sets of clients that combine get gigabit speeds, but it's a marketing stretch, is what I'm saying.
I hear
it's
you
not
loud and
reality.
clear. I hear you loud and clear. It is a marketing stretch, but like I say, to explain it again, we can get a cell that will support 900 megabits worth of bandwidth, and it's a shared medium. It's not an individual medium, because every time, so you'll have two, yeah, I see what you're saying. Because at the max, one client's going to get is 450 megabits if they have a 3-stream radio in their client.
Well, that's raw data rate.
And that's raw data rate, it's throughput. Oh, as I said, we can get back and forth on the numbers. It's always raw data rate is what we talk about, because even the throughput's going to vary, you know, a foot away from the AP. So you always got to talk about the theoretical maximums.
I think Jennifer had a question.
I just wanted to say that
Yes,
the
Jennifer.
point that I find the most striking about the 466R versus the one that I'm used to deploying outdoors is that it weighs about a third of the AP that I typically install outdoors. And I think that's a stronger point, just right there. The smaller weighs less. I just wanted to throw that out there.
Less likely we're at the
That this
shootout.
one weighs less?
Yes.
I'll have to mark that down. This would be another good marketing point. I can bring in our competitive guides.
Yeah.
So when you're holding it up on the pole, it
Just
doesn't
period
stress your
installing
shoulders?
it to the side of the building, a bracket, anything, it's about 6 pounds, and the leading competitors is anywhere between 17 to 18.
Just
not
watch
including
Jennifer
others.
try to get her survey kit into the back of her car.
Perfect.
video.
Exactly.
I like that.
Exactly.
I'll have to use that. Thank you,
Video for
Jennifer.
that?
Exactly. I have a demonstration video on YouTube, yes. I was so frustrated, yes.
Okay, well, thank you. I appreciate that. I'll take that one home with me for sure. All right, and deployment. Here we have a deployment guide, and I just picked some of the highlights out. So this will vary. Outdoor deployments are totally separate from indoor deployments. You've got to worry about the Fresnel zone, how high the antennas are. Is there leaves on the tree? You know, all this fun stuff that you have to do for outdoor deployments. But typically, with a 2.4 gig range with a point-to-point antennas, a 10.9 dBi gain, at a mile, we can get about 120 megabits per second, and at about 3 miles, we can get about approximately 50 megabits per second. Okay? In a 5 gigahertz range, with a 13.5 dBi gain antenna, at a mile, we can typically get 100 megabits per second, and at 3 miles, we get about 10 megabits per second. And the reason why is 5 gig does not traverse through the air as far as 2.4 gig does. It's a higher wavelength. It doesn't traverse through the air as far. So if you use a point-to-point and an omnidirectional antenna, do the point to multi-point types of distances, you get about half the distances of what we set above for those speeds. Okay? And then an omni to omni, we never recommend it. It's not a good idea, but you get about a quarter of the distance above. Okay? And then one note, in both cases of 5 gigahertz, you get a little slightly better performance in high interference environments. Okay, so that's just a guesstimate. This is out of our deployment guide. I just wanted to highlight it so you can see where it's really important to utilize them. All right. Here's a functional block diagram. Looks the same as the 466 and the 460. And then we have our antenna connectors, and these can be internal or external. But this will be actually external antennas only, and the same block diagram with the 460, they'll be internal. 466 will be external, but it's the same exact insides, just a hardened case, ready for outdoor use. Okay, and one antenna I didn't talk about, we have a 3x3 MIMO outdoor antenna. These come with the end connectors on them for direct connectivity for outdoor usage. And you have to order them in either a 2.4 or 5 gigahertz version. They're not both. Okay? And typically you see these in a point to multi-point type environment. This will be the center. Everybody will be pointing to it. All right. Any questions? Is this what the kind of stuff you guys want? I mean, am I going down the wrong path, or?
A little too high level. We want nuts and bolts, gears and knobs.
So you want to actually touch it and...
If you could just give us a screwdriver and a whole bunch of those.
You'll be good to go. That's why I'm trying to throw in some block diagrams here and there so you can actually see what we're doing inside. Okay.